Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with MetaGeek. Today's host is Casey Cathy. He is their customer service experience specialist. If anyone has any questions, please feel free to submit them in the question box, and I'll ask them to Casey at the end of today's presentation. Casey, I am finished for now. Thank you very much for being here today. You can go ahead and take it on over.
Awesome. All righty. Thanks, Julie. Thanks for joining, everyone. This webinar is going to showcase some of the core products that MetaGeek has to offer, which are all available at Microcom. On the agenda today, I'm going to introduce myself and talk about MetaGeek, the company that makes these tools and this software. I'm going to go over some Wi-Fi fundamentals, which are pretty important to understand Wi-Fi and kind of how our products work. We're going to go over inSSIDer Office, which is our basic Wi-Fi scanning tool. I'm going to go over our Chanalyzer software, which is a spectrum analysis tool. And then we're going to take a look at Eye P.A a little bit, which is a packet analysis tool, kind of that next layer, which we'll get into. And then, of course, we'll open up the floor for some questions. About myself, my name is Casey. I am the CX specialist, as Julie mentioned, here at MetaGeek. So if you send in a support ticket or something to MetaGeek, chances are it's going to be me responding to you. I have a few certifications put on by a company called CWNP, which I highly recommend checking out if you want to further your knowledge on Wi-Fi. I'll get a little bit into some Wi-Fi stuff, but I'm not going to get too technical. To really learn some of the technical pieces of Wi-Fi, a lot of the important data to know, I definitely recommend checking out the CWNP certification program. I just recently grabbed my CWAP at Wi-Fi Trek this year, a few weeks ago. And so I just need one more certification to try and fill out that Certified Wireless Network Expert certification. You can also find me on Twitter at CathyFi. I usually just do support there, but there's a really great community on Twitter that I recommend checking out if you do have some questions about Wi-Fi or things like that. It's a pretty welcoming community, a lot of experts on Twitter as well. And if you just look at some of the people that I'm following, most people on this account are all really high-level Wi-Fi experts, so it's probably worth following them as well. About MetaGeek, we're based in Boise, Idaho. This is a picture over here of outside our office window in downtown Boise. We really love it here, and pretty small company. And again, we just focus on making Wi-Fi troubleshooting tools. So the first thing I kind of want to jump into is the concept of Wi-Fi being half duplex. And this just means that only one Wi-Fi device can talk on a channel at a time. To kind of visualize this, you want to kind of think about an Ethernet cable, right, which isn't Wi-Fi, it's cabled. Ethernet cables have a twisted pair of copper cables inside. And this allows traffic to go two directions at the same time, which is why it's always preferred to use an Ethernet cable, because both devices can talk to each other at the same time. Whereas Wi-Fi, on the other hand, it's a lot different. Wi-Fi is kind of like a single lane highway, and really only traffic can go one direction at the same time. You really can't go two ways at the same time with Wi-Fi, and that's a really important concept to keep in mind. As you're kind of thinking about how our tools kind of display this and show this. So again, in this example right here, let's just say we have a client device like an iPhone having a conversation with an access point, right? Maybe streaming Netflix or something like that. So it sends a request, and the access point says, check, I'm going to begin this conversation with you and start giving you the data that you requested. What that means, though, is that every other device that is connected to this network, whether this is an office network or a home network, whatever devices these are, whether they're laptops or other people's iPhones, other people's, Android tablets, they actually have to wait their turn to talk until this conversation is over. And so as you can see, obviously, the more client devices you have, the more issues that arise. It's actually kind of fascinating that Wi-Fi works at all when you think about this. And so I want to talk about a couple of the bands that are licensed by the FCC to be used for Wi-Fi. There's really only two. At the moment, two main consumer bands that are used. There's the 2.4 gigahertz and the 5 gigahertz band. So obviously you guys have probably know about this a little bit, but the 2.4 gigahertz band, the wavelength here is a lot wider. The distance between two wavelengths on the 2.4 gigahertz band, about from here to here, is about 5 inches total. And what this means is that it can go farther distances. It has greater range. We're looking at about 300 feet indoors or so. Almost everything works in this band. Almost any device that you guys will receive will be capable of working in the 2.4 gigahertz band. So usually it's important to deploy. It's becoming less important now, but it's definitely universally accepted. As a result, it's also congested with Wi-Fi. Since everything runs in this band, typically this band is very much congested, and it can be hard to see this sometimes. And also there's a lot of non-Wi-Fi devices that operate in this band as well, like baby monitors and microwaves and Xbox controllers, things like that. That non-Wi-Fi devices also tend to operate in this 2.4 gigahertz band. And there's only 3 non-overlapping channels, 1, 6, and 11. So what that means is I'll go over this in a bit, but long story short, those are the only 3 channels in the United States that you should probably select your network to operate on, 1, 6, or 11. The 5 gigahertz band, on the other hand, the wavelength is a lot shorter. It's kind of like this, and the distance here is about 2.4, 2.5 inches. And what this means is it has a lower indoor range. So you're looking at about 90 feet indoors. Things like walls and metal and doors, that's going to attenuate the signal a lot more. It doesn't pierce through those materials as well. And it also has a little bit of a limited compatibility. Only higher end devices will typically support the 5 gigahertz. This is kind of changing. It's becoming more accepted to include a 5 gigahertz chipset in most devices these days. Back in the late 2000s, early 2000s, this was a lot more rare to see. Typically, any higher end device, like I said, is going to support this. And as you can see, there's just a lot more room here as well. There's 24 non-overlapping channels in the 5 gigahertz range. So it's recommended to, if you can, deploy a 5 gigahertz network because there's so much space to use, and it's just a little bit more throughput possibilities as well, which I'll get to. Kind of a quick history of Wi-Fi. Obviously, Wi-Fi started in 1997. And with 802.11 prime. Oops. Let me go back to that real quick. And 802.11 prime here, and then in 1999 we came out with 802.11b and 802.11a, which opened up a few more data rates here. But the main thing I want you to take away from this is that the modulation schemes that we used here. So for prime and 802.11b, we used direct sequence spread spectrum. And what this looks like on a spectrum analyzer is kind of a curved shape like this. And you'll still see this today because a lot of stuff resorts back to these old data rates, and a lot of management overhead resorts to these data rates. So it's really important to know what this looks like. And this is about 20 megahertz wide. This is what a typical Wi-Fi channel is going to look like using direct sequence spread spectrum. Now, once we introduced 802.11a in 1999, we started using orthogonal frequency division multiplexing. And you don't have to know that, but what is important to know is that created more of a haystack shape, kind of like this, a little more linear, not so curved. It allowed us to achieve higher data rates and become a little more efficient on the channel. It's still 20 megahertz, or it can be up to 40 megahertz. Of course, with 802.11ac, you can get up to 160 megahertz wide channels. And it's all going to look like this on a spectrum analyzer. That traffic is going to have this kind of straight linear shape. And then, of course, AX is going to be coming out here pretty soon. And while it's not going to open up a new band or anything like that, it's still going to, reside primarily in the 2.4 and 5 gigahertz band. As long as you have a chipset that supports AX, and right now there aren't any client devices that are currently being supported. As long as you have a chipset or a laptop or an adapter that supports AX, our software is going to see it. Remember that MetaGeek sells a raw spectrum analyzer, so as long as it's making noise in the 2.4 or 5 gigahertz spectrum, our products are going to see it and be up to date there. And kind of going back to the overlapping channel issue, in the 2.4 gigahertz band, you have to remember each channel is only separated by about 5 megahertz right here. And so as a result, there's only 3 non-overlapping channels in 1, 6, and 11. And so really those are the only channels you'll want to use here. Again, you can use up to channel 13 in some other countries, like Japan, for instance. And so sometimes in those Asian countries, you use 1, 5, 9, and 13 as those are the only 4 non-overlapping channels. But yeah, the entire spectrum is only 60 megahertz wide, which is why we typically recommend going over to the 5 gigahertz. So in the 2.4 gigahertz, you tend to see these types of Wi-Fi interference a lot. You see co-channel interference, which is other neighboring networks are sharing the exact same channel as you are. And then you see adjacent channel interference, which is a neighboring network is sharing a channel right next to you. Because remember, there's only 5 megahertz of separation between a channel. So if you're on channel 6 and you have a neighboring network on channel 5 or even channel 4, some of their traffic is gonna interfere with your traffic here. This might cause some retransmissions from your clients. This might cause your clients to drop off the network completely because basically there's so much noise on a channel, and it depends how much it's being used, but your clients will just have to yell over each other. So we'll go over this a little bit more later. And so, this is where spectrum analysis comes in handy. And we do sell a spectrum analyzer called the WiSpy. And it basically allows you to see all of these types of interference. And more importantly, though, there's this final type of interference, and that's non-Wi-Fi interference. So, we're looking at Wi-Fi 802.11 activity over here and over here, but this could be a cordless phone or a microwave or baby monitors, things like that. And so it's really important to have a spectrum analyzer of some sort because you never know when those types of things are interfering. This slide kind of captures it really well as well. Using just a basic Wi-Fi scanner, you might see an image like this. You see your networks, you see the signal strengths these networks are operating at. You can look at some adjacent channel interference here. You see that there's a possibility for something going on. But what you don't see until you get a spectrum analyzer, what you don't see is if there's something like this going on. This looks like a non-Wi-Fi interferer right here, just because it's only about 5 megahertz wide, maybe. It's clearly not 802.11. And so that's where a spectrum analyzer is really handy to have, because you wouldn't know otherwise that channel 11 is not the best channel to select there. I'm going to go over a little bit of Wi-Fi coverage for you guys. This is probably our #1 viewed article on our support knowledge base, which I recommend visiting for some Wi-Fi knowledge. But kind of the takeaway point here is, if you're wondering what a good signal strength is to achieve throughout a office or a house or wherever you're deploying Wi-Fi, we really like this number at MetaGeek, -67 dBm. Typically at this signal strength, you can pretty much do anything you want. Google Hangouts with video, you shouldn't be dropping any frames at this signal strength, as long as the noise floor isn't too high, right? As long as there's not any interference right next to you. But -67 dBm, this is a good signal strength to shoot for. As soon as you start getting a little bit lower than that, -80, -70, -90, that's when you can start kind of experiencing frame drops. Voice might start getting laggy, things like that. So we always say -67 dBm or better. Our software groups has 2 different kind of grouping modes depending on what task you're trying to do. If you're trying to diagnose a problem with an access point, say you have one access point that's kind of an issue, you'd want to use physical grouping. This will basically group all the SSIDs onto the same access point, so you can kind of troubleshoot one access point. These would represent your virtual SSIDs, like a guest network or things like that. whereas a logical mode will kind of group all those together into the same SSID. So even if you have multiple access points, you can kind of troubleshoot things like roaming issues with logical mode. And again, I recommend kind of using the trial of our software. If you just Google a trial version of MetaGeek software, you'll be able to kind of see how these groupings work. And with that, I'll go ahead and open up inSSIDer Office and kind of show you guys some things, how this software works, kind of what it's used for. One thing to keep in mind is that inSSIDer Office is a snapshot tool. It's a really good tool to just quickly bust out and kind of see what's going on the network and kind of see what's going on. So right now I'm actually working from home. And so this is actually just my neighborhood. These are all my neighborhood networks going on. And right now I'm in physical mode. So I'm going to go into logical mode and show you kind of these SSIDs. And there's actually a lot of activity here. I forget how congested my neighborhood can be sometimes. So one of the best features I really like about inSSIDer Office is this filter feature. I'm going to go ahead. My network here is called Kathy5. I'm just going to type in Kathy, hit enter. And right off the bat, I can kind of isolate that out and just look at one thing here, which is my network. And what's really nice too is inSSIDer Office shows this little link sign. This shows that I'm currently connected to this network, which is really nice. If I had multiple APs, it would show you which AP you're actually connected to, or exactly where you're connected, which is really nice. Right now, I just have a dual band router. It's just an Apple Airport Express. And so it's just broadcasting one network on the 2.4 and one network on the 5 gigahertz. And of course, if I go into physical mode here, I can find that I am indeed connected to the 5 gigahertz network on channel 48 and 42. And I have a really good signal strength, which is good. It looks like this traffic right now in doing this webinar isn't really doing much. You can kind of see this blue spectrum here. I have a Wi-Fi DBX plugged in, so I'm also looking at spectrum. Not a lot going on here, which is good to see that this isn't taking up too much bandwidth on my network. If I had a neighboring network or a neighbor that wanted to use the same channel, chances are he could also talk on this channel, which is pretty cool. Another thing I kind of wanted to show you that I really like about inSSIDer Office is it takes the guesswork out of things. So right now it shows that I'm on channel 48, and we have this recommended feature. It actually recommends channel 60, which is about right here. And it's probably looking at this activity, this kind of blue activity here. It probably sees this and says, looks like this is in use. You typically in the 5 gigahertz, it's going to recommend, anything that's clear, but usually the 5 gigahertz is going to be good to go. If I go to the 2.4 though, this is where the recommendations really come in handy. The 2.4 right now, I'm on channel 6 and it's recommending channel 11. So if we were experiencing Wi-Fi issues here on this network, I would this would be one of the first things I would try, which inSSIDer Office just is really nice for that. Kind of recommending taking the guesswork out of it, especially if you aren't an expert or if you have technicians that aren't Wi-Fi experts and just need to know what to do quickly. And if you're curious about how this number is given or how this channel is recommended, to figure out how it's doing that, I'm going to pop over into the channels table here. And I want to focus just on the 2.4. So I'm going to draw a line here. Just to kind of separate out the 2.4 channels from the 5 gigahertz channels. And if you take a look, we really pull 3 things into this equation: channel utilization, co-channel networks, and then adjacent channel networks, which I was kind of talking about earlier. And so the channel utilization, this is only given to you if you have a Wi-Fi plugged in, and the Wi-Fi is our USB spectrum analyzer, and this is just measuring raw RF on a channel. So as you can see, channel 1 has about 6% utilization, and it's literally looking at this. If you're curious, it's basically from 20 megahertz out. So basically from about here to here, it's just measuring all the RF activity on a channel. Channel 6, on the other hand, is showing about 8.6%, and channel 11 is about 8%. And so it's all pretty even, honestly, when it comes to RF utilization on a channel here. Kind of a big difference here, though, is channel 1. It looks like there's 17 networks in this neighborhood on channel 1, and that's probably why you can kind of see a little bit more of a curved shape right here. That's just 802.11 activity. These could be really far away. It just depends how strong your Wi-Fi adapter is. Right now I'm using the Broadcom, which is built into my laptop. These are pretty good Wi-Fi chipsets. So it's probably seeing a lot of stuff around me, even if they're far away. Not going to be too much of an issue, but it certainly can be. And then, of course, it's seeing 11 overlapping channels on channel 1. So that just means there's some other stuff going on channels 2, 3, and 4. Which is quite a bit, actually. So that's clearly why Insider Office did not recommend channel 1 for me, which is really neat that we don't have to go and look at these numbers. And then, of course, channel 6 only has 5 or 6 on-channel networks. Looks like it has a ton of overlapping networks, again, which is probably why it wasn't wanting to recommend that one as well for me. And it looks like the utilization on channel 6 just spiked significantly as well. That's what's kind of cool about this tool. It uses a 30-second time span, and as I'm giving this webinar, you can see some 802.11 activity starting to build on channel 6. So someone's using the Wi-Fi on this channel. I don't know if it's someone on this network or if it's this laptop, or if it's a neighbor that's pretty close to me as well, because the amplitude, which is how tall the signature is, that tells you how close. So this is pretty close. Looks like it's at about negative 65 dBm here, this signature. So if it isn't this network, it's one of my neighbors near me. So thank goodness I have a 5 gigahertz network set up here. I think that's about all I wanted to show you with Insider Office. Again, like I said, it's only using a 30-second time span to show you this spectrum. Of course, if you wanted to, you could actually make a recording. You could start this recording and walk around, and then you can actually open it up in our other tool, which is called Chanalyzer, which I'll show you here in a second. I'm going to kind of discuss Chanalyzer. So, what if there was what if there was some sort of interferer that we couldn't really troubleshoot? Say we didn't know what this was, for instance, this signature right here, or say there was an issue that was more intermittent. Maybe we couldn't catch it when we opened up Insider Office, but the customer is complaining that there's an intermittent Wi-Fi issue. Well, that's when you might be interested in our next tool, which is Chanalyzer. We call this the deep dive into spectrum analysis. This is the cable tester of Wi-Fi. Since Wi-Fi operates in invisible RF medium, this lets you see the invisible. So like I said, you can locate sources of interference. Chanalyzer is typically sold with a directional antenna as well, so you can actually directionally locate sources of non-Wi-Fi interference. Things like monitors, cordless phones, microwaves, wireless video cameras, etc. And here's a little GIF of the device finder in action here. You basically unscrew the omnidirectional antenna on your Wi-Fi, and you plug in the device finder antenna, and then you can start locating those sources directionally. And like I said, this is kind of similar to only one channel or one device being able to talk on a channel at the same time. Well, turns out that non-Wi-Fi devices, when they enter the same area as a network and clients, all these client devices think it's a Wi-Fi device, and they will actually wait their turn to talk until this microwave, for instance, is done talking, until your burrito's done microwaving, done cooking. And so it's actually, this happens all the time. I see this all the time with customers where a microwave or something will just completely cause havoc on a channel, and all the devices will drop off completely. So it's really important to be able to see this non-Wi-Fi interference. Here's some good signatures of a baby monitor. It's kind of fun to go through what this looks like in Chanalyzer. These frequency hops, so as you can see here, this was on channel 9 for a minute. Looks like it went to channel 5 for a minute, channel 1 for a minute. So this is really frustrating when you're trying to troubleshoot some issues. Baby monitors are not fun at all to have in the same realm as your Wi-Fi. Bluetooth kind of looks like this. It frequency hops as well. but very quickly and very fast. Typically, Bluetooth does not interfere with Wi-Fi because it's so fast and so quick, unless you have a lot of it. I think this was like 100 devices when we took this recording. So this is what 100 devices operating in Bluetooth looks like. Typically, you're not going to see that unless you have, again, tons of devices. This one I always like to show because this is what those old analog wireless video cameras looked like, and these would wreak havoc on Wi-Fi as well, just because they're so wide and they just don't let any time to talk for any Wi-Fi devices. One of the biggest selling points of Chanalyzer is that instead of just a 30-second time span, which is what inSSIDer Office offers, you can record for as long as you want, as long as your computer has enough memory for it. And you can pause that spectrum data, you can rewind it, you can isolate it and troubleshoot. So it's a lot like a DVR is kind of how we like to sell this tool for your spectrum data. And of course, we also have a report builder feature, which makes you look really professional. You can just hand a report over to your customer and kind of show them what's going on with your network. And then if you deploy Cisco access points, you can actually, you don't even have to go to the environment. You can remotely tap into the spectrum capabilities of clean air enabled Cisco access points. You just need an IP address and an NSI key for that. And that's a pretty neat feature to have. So I'll go ahead and kind of show you what Chanalyzer looks like. I'll just hop in here. So as you can see, it's pretty similar right off the bat, pretty similar to what inSSIDer Office looked like. I'm going to go ahead and quickly just do a dual band sweep here. So I'm sweeping both the 2.4 and the 5 gigahertz, which is the capability of the Wi-Fi DBX. And again, it's pretty similar to inSSIDer Office in that you can kind of overlay your networks. If I hop into the 5 gigahertz here, you can kind of see my living room access point showing up, and you can kind of troubleshoot. And it looks like there's a little bit more throughput going on now in this current environment. And what's pretty neat, I'm going to go back to the 2.4 here. And there's that signature again. So it looks like the 2.4 is getting used quite a bit here. But if you didn't know that, one thing I really like about about Chanalyzer, if you go to the interferers tab down here, you can actually begin to identify what this is, and that's what kind of separates this tool out from inSSIDer Office. So say I didn't know much about Wi-Fi. Say I thought this was an AV transmitter. You can actually click on this signature and drag it up, and you can kind of match it and see if it matches. And I can say, oh, this doesn't really match. Clearly, it's not an AV transmitter. This is an RFID reader. No, it doesn't really fit. Doesn't really work. And then, kind of I can see this looks like 802.11b activity. And sure enough, you kind of hover that over there. That's pretty spot on. That's pretty close. You can actually kind of scroll up or down if it looks like it's closer. So now that I kind of scrolled up, it looks like, yeah, this looks like pretty near 802.11b technology. You can even see that little divot there in the center, which is that null carrier pilot. And if you learn more about RF, you'll kind of know how the data is transmitted here. But you can actually even see that pretty clearly. So that's pretty neat that my environment right now is giving this real-time example, and you can actually kind of troubleshoot and identify this source of interference right now, which happens to be Wi-Fi 802.11b. What this probably means is, clearly there's tons of G, N, and you would expect to see something like this. But when a network gets bogged down so much, it actually will resort to 802.11b modulation, that direct sequence spread spectrum that I was showing you guys. And so even if you have the fastest GN, AC network, sometimes you will see something like this if it's getting used too much, because it has to resort to those lower data rates to accommodate all the devices or the limited bandwidth available on a channel. One other thing I kind of want to show you here is a recording that I have pre-recorded here. And of course, people can send in recordings, and so sometimes I get some really neat recordings. I think this one that I want to show you guys was actually created by MetaGeek. And so this is another really good use case of identifying a non-Wi-Fi interferer. So if I go to my networks table here, you can see that there's a couple SSIDs going on. I'm going to go ahead and place a check mark by those to show them in the amplitude graph here. And so we have a MetaGeek network. Looks like we have a Redfish network over here with the SSID Redfish. And if you guys pay attention over here, and I'll get my annotation tool, you can kind of see this. This is the waterfall graph over here. And so you can see it's timestamped. It started at 9:28 in the morning, and it looks like we only took a 10 or 11 minute recording or so, very small recording. You can see 9:34 a.m. right here. You can kind of see after 9:30 in the morning, you can see this red line here in the waterfall graph. And so if I wanted to kind of take a closer look at that, you can actually just click and drag around it. And this will put the time sliders right around that signature, and bam, it just shows up immediately in the amplitude graph, and you can start to troubleshoot what this is. And so if I didn't know what this was, I could actually go to the interferes tab. And again, like I showed you earlier in my live environment, you can start pulling up some signatures and kind of seeing what this looks like. And this actually ended up being, I think this was some sort of cordless phone. So this signature is pretty close here. I think it was a Uniden phone to be exact. So I think it was this one right here. And so this is a great tool to, again, kind of troubleshoot and identify and figure out where this was. And if you didn't know where it was, this is where the device finder directional antenna would come in handy. You can actually start to locate this a little bit more directionally. And of course, I was kind of talking about the report builder feature. If you wanted to throw this information in a report, let me go ahead and clear out my drawings here so those don't get in the way. Basically, you just go, very easy to use. If you wanted to kind of add what was going on in the density graph at that point, you just click the plus sign here and click density graph, and it's going to throw in this this image of that cordless phone there. And of course, it gives you what's really nice is it kind of pre-populates some text in here, and it explains what you're seeing to this user. So it even explains the color schemes that we use, which I recommend checking out as well, which is available on our website. If you see blue in the spectrum, it just means less than 10% of the spectrum is being utilized, which is good. It's more like a clap, right? If I clap right now, it doesn't really interrupt our conversation. But if you start to see green, yellow, red, that just means that more and more that channel is being used. So red would be something like an air horn. So if someone came in here in my room and started blaring an air horn, that would start to interrupt us, right? You wouldn't really be able to hear me because all you'd focus on is this air horn. And so that's kind of what this the colors mean here, and we throw that automatically in this report for you, so your customer doesn't have to guess what these colors mean. They kind of understand what this means. And of course, there's a lot of things you can add in here as well. You can add the networks table, the current signal strengths, the data rates, things like that. It's a really neat tool to have, and you can just hand this over to the customer. This is good for doing kind of before and after as well. Here's before I worked on your network, here's after I worked on your network and got rid of these sources of interference, things like that. So that's kind of the good job to be done here. And lastly, the last thing I kind of talked about was this Clean Air accessory. It's just an accessory that Microcom and MetaGeek sell standalone. If you just have the IP address and NSI key. I don't currently have a Cisco AP or anything like that I can connect to, but this is a pretty neat feature to check out. And so again, this is the deep dive into spectrum analysis. This is layer 1 troubleshooting. The next tool I want to talk about goes over that next layer, layer 2. If you guys are studying the CWNP, you know that there's a OSI model that kind of just goes up to the application layer ultimately. But we start with the physical layer, layer 1, which is what I just showed you, spectrum analysis. And then the next step, if there's still some issues going on that you guys can't troubleshoot on a network, and you know it's not interference, and you know it's not something else, then you want to move to that next layer, which is layer 2, the packet data layer. And that's where IPA comes in. So as I was showing you, spectrum analysis will kind of show you the sum of activity on a channel. Packet analysis really shows you more of the details about those conversations happening on the channel. You really get to dive in and see, okay, what's being said here between a client and an access point. It's really important to remember that Wi-Fi is half duplex. Again, this is such an important aspect here. If two devices try to talk at the same time on a channel, they will cancel each other out, and they'll try and retransmit that data if there's no acknowledgement coming from the access point. And that's where you get the term retry rate, which is something that IPA will actually show you. And this is another important thing to think about when you think about data rates. So if you have a slow device here, let's just say you have this this device here, an old Android phone, and it's far away from the network, far away from the access point. It has to have this conversation at 1 megabit per second, let's just say, which is the lowest data rate. This access point sees that it's trying to request some data, it says check. And if this data, let's say this guy's trying to watch a YouTube video or Netflix or something like that at 1 megabit per second, what that means is these other devices, which maybe are even right next to the access point, maybe they can achieve higher data rates like 54 megabits per second or something like that. They still have to wait their turn to talk and wait for this slow guy right here to finish its conversation. And IPA can help you kind of see that. It shows you the data rates of each client on a network, and so you can know if you have some of this bottleneck issue. It kind of displays this. It shows you this in 3 different frame types, which are the 3 frame types of 802.11. We do have management frames, control frames, and data frames. I don't want to get too far in the weeds here of how these work, but management frames basically help stations and clients get on and off a network. You probably know what beacon frames are. Basically, for instance, at my house right now, I told you I have an Apple Airport router or access point, and about 10 times a second or every 100 milliseconds or so, my network sends out a beacon, and it says, hey, I'm Casey's network. I'm here. I support these data rates. I support this encryption. You can connect to me. Literally 10 times a second, which is crazy. It beacons out. Every other network that's around me does the exact same thing. And that's how we're able to see those networks when you pull up your iPhone and you want to connect to Wi-Fi and you see all those networks. It's because they're beaconing, 10 times a second. And those are management frames, which you can see inside IPA. And the probes are kind of like the opposite of beacons. This comes from your actual client device. So my iPhone, for instance, since it knows, any network that it's ever connected to, it's actually sending a probe for that network saying, hey, Kathy-Fi, are you there? Our MetaGeek office has a SSID called MetaGeek. So my phone is constantly probing for that. When the Wi-Fi isn't connected, it says, hey, MetaGeek, are you there? It sends these probes, basically these probe requests, which is why, kind of back in the day, they recommended you turn your Wi-Fi off if you were like on the road or something, because it does consume battery to have these devices constantly sending probe requests to connect to networks that it's never going to connect to. Even, I connected to the Boise airport once. So my phone will now send probe requests to the Boise airport specific SSID. It's kind of crazy that happens, but that's just in the 802.11 protocol. And then, of course, if you have WPA or some sort of security, there's authentication and then association frames as well. And those kind of those are the management frames that IPA shows. Control frames kind of help make sure that those management frames get delivered properly. A lot of times I like to compare control frames to kind of like a walkie-talkie. When you're having a walkie-talkie conversation, you say Roger, right? You kind of acknowledge when you receive a message. It just helps the sender of the message know that they received your message. So that's what an ACK is. It's an acknowledgement. Like, yep, I acknowledged what you said. And you're clear to send. And that's what RTS-CTS is as well. This is just request to send coming from a client device, and then the access point responds, you are clear to send. Let's see what you got. And then, of course, data frames. And these are these are the only frames that actually go up the OSI model that I was talking about earlier. The other frames I just talked about are specific to wireless medium, wireless traffic, 802.11 traffic. data frames, this is your actual, this is actually if you're requesting a YouTube video, this is the actual video data, right? And so these are really important to see. You want to see this typically when you perform a protocol capture. You want to see a lot of data flying back and forth. You know that the network is performing correctly. So blue is usually a good thing to see on these packet captures. The Airtime arbitration process, this is basically how devices decide to talk first on a channel. I'm not going to get into this too much because this is very complicated, pretty hard to understand sometimes, and this is more for people who do want to get their CWNP certification. But basically, the takeaway point that I want to have you take away here is, for instance, we'll just station 1 and 2. Station just means this can be an access point or a client, and this is all on the same network. All of these clients are access points. Basically, what these clients do is they roll the dice. As a good metaphor, is they just roll the dice with each other and say, okay, who gets to talk first? And so in this instance, station 1 rolled a 7. And station 3 here rolled a 9. And so they both counted up to 7 and 9. And as soon as 7 hit, station 1 sent a request to send, and it got a clear to send, and it began its conversation. Meanwhile, these other stations all had to wait their turn to talk. And since they rolled higher numbers here. And then once this conversation finished over here on station 1, the remaining 2 slots that it rolled, since it rolled a 9, they start counting that, and then this station now begins to talk. So kind of the take-home point here is that clients essentially just roll the dice for who gets to talk first, and so this is kind of important to look at in a protocol analyzer to see, okay, who's rolling what, and is this fringe network or this fringe client device rolling a lot of high numbers here. This can kind of be difficult with tools like Wireshark, you might have heard of, which is a free protocol analyzer. This is a screenshot of what Wireshark looks like. It can be kind of hard to figure out what's going on. There's a lot of good data in here if you know what to look for, but sometimes it's really nice to just bust out a tool like Eye P.A, which immediately aggregates all this data and puts it in a nice visual pattern. As you can see, Eye P.A will start off with this, it kind of has a multi-layered pie chart is what it looks like. And it starts off with the network, so it's really easy to kind of diagnose and see what's going on. So it starts off by this innermost piece here shows the network, right? So this would be like this particular one is a Bronco guest, which is at BSU, a college here in Boise. And so the next layer out shows an access point, right? So this particular access point was taking up about half of the airtime. You can see this entire circle just represents the airtime on a channel. And so you can see this one access point in this location was taking up half of the airtime, which is quite a bit. And then the next slice out, this shows the client device. So maybe this, for instance, was an Apple, like an iPhone or something like that, right? And then finally that next layer out, as I showed you, data frames are marked as blue. There's a lot of data being passed. So this is probably a good, healthy transmission here. This could be an iPhone, and this could be, YouTube traffic or something, some sort of data, Facebook, Netflix, and it looks like about a quarter of this airtime here was being used for this one client device. So it's really nice, really cool to be able to see this that quickly. Something Wireshark certainly does not produce in that amount of time. And like I said, that very outer ring is the frame type. Really nice to visualize that there's a lot of data on this one. For instance, this blue, you can see, purple is management. You don't want to see too much purple because management is just there to get the data across, and same with control frames. You don't want to see too much of those colors on a network. You have some issues if you do. Eye P.A supports a few different sources, and I'm really excited. Actually, we're about to release a update to Eye P.A where even more sources are being accepted. But right now, natively, we do support a specific set of Wi-Fi adapters. We prefer the Linksys WUSB 6300. Literally, it works within IPA. You don't have to grab a PCAP or anything like that. And we also have a list of those sources on our website that you can use. You might have one right now. You might even be able to use the trial version and start using the software in your environment if you have one of these adapters. We also recommend Mac OS has really great MacBook adapters or packet capture adapters built in. The latest MacBook Pros have 3x3 spatial streams, meaning it captures a lot, pretty much, unless you're in a really enterprise environment with they're using 4x4, spatial stream APs, you're going to be able to capture every piece of data with the MacBook Pro. And what's nice is you can actually just export that into a PCAP, which is readable in IPA. So you can just analyze that PCAP in IPA. And what's cool here, this other sources, this is what we've worked on more. So you can also use enterprise grade access points to generate PCAPs. And literally, probably in the next week or two, we're going to release an update that allows a lot more sources. Before, we had troubles with certain Cisco APs. We had trouble with some Ruckus APs. We had a couple of troubles with Aerohive APs. Those all work now really well. And before IPA only could analyze 802.11 traffic, of course, some of those access points will show you Ethernet traffic, UDP and TCP traffic, which we now actually will show you in IPA as well, which is really cool. It used to break IPA and crash it, but our engineers have been really hard at work to keep this software up to date and import more sources of PCAPs. So yeah, with that, I will go ahead and open up IPA and kind of show you a couple of things, and we'll open up the floor for some questions after that. So yeah, the first thing, this is kind of what you see if you were to get the trial version. Just a couple demo files that you can open, which are really cool. Actually, I do recommend just Googling IPA trial, grabbing a trial of this software, and then if you like it, of course, go through Microcom and purchase a license. If you have your own adapter, you can click capture here. Again, check our website to see if you have a device that will allow you to capture natively. If not, it's always fun to kind of poke around in some recordings. The first one I want to show you is this example recording called virtual SSIDs. This one's pretty exciting because a customer actually sent this to me. I think he was a network administrator for some university, and he was just complaining that the Wi-Fi wasn't working at all, and client devices weren't connecting to the network, and just tons of issues. And I said, hey, send me a PCAP. I also had him send me a Chanalyzer recording. It's kind of I like to consult and help customers out as much as possible. And he sent me this, and right away, you guys remember when I told you that purple means management frames. Right away, I was kind of blown away at what I saw. This is like a perfect, almost like lab environment of what management overhead looks like. And one thing I kind of want to show you guys is this customer had, how many here? All these virtual SSIDs over here, right? They had like a staff network and a student network and a guest network and a bring your own device network and another guest network for some reason and a VR network, right? For different departments. And all that was causing was just all of these networks saying, hey, I'm here, I support these data rates, connect to me. Hey, I'm here, I support these data rates. All of these are actual networks right here, which is just fascinating. AP's broadcasting virtual networks, I should say. And so this purple just represents management overhead. As you can see, there's almost no data actually being transmitted on this channel. This is, and you can see the airtime here in this airtime chart. You can see about a quarter of this airtime is just being consumed by nothing but management. Like I said, 10 times a second, each one of these virtual SSIDs that they have set up is broadcasting, is beaconing, saying, hey, I support these data rates. Will you connect to me? And that's just a complete waste of airtime. If there were to be data transmitted across this channel, it's already only got 3/4 of the possible airtime here. And this is why we recommend at MetaGeek really try and keep your virtual SSIDs down to 2, maybe 3 at a maximum. Once you start getting more than that, you just start eating up all your airtime with management overhead, which isn't nice. And of course, one kind of cool thing, if you did want to dive into a specific issue here, let's just say they wanted to look at this the students network here, you can actually click on that little piece of pie, and then of course it breaks down to the access point here. One more layer is the client, remember, and then the actual frame type, which these are indeed beacons, as it will give you the frame type. So these networks are just beaconing here. If you wanted to just kind of troubleshoot this piece right here, a really cool thing that you can do, and I'll kind of show you as well here in the packets. So right now we're only looking at these packets, and this looks a lot like Wireshark, right? If you wanted to dive into some of these frames, you can actually go to File and then send a Wireshark. And at this point, it just opens up Wireshark with this filter that you put on it specifically. I'll skip this, and then you can start to dive into those very specific filtered packets and those frames. And of course, you can do a lot in Wireshark. We deliberately don't give you this information because there's a lot of complicated information, and Wireshark does it great already. So why reinvent the wheel? If you know what you're doing in Wireshark, you can go and troubleshoot frames further. Eye really is just an excellent filtering tool at that point to really quickly get you to where you want to be looking at, right? Say you need to troubleshoot a different SSID. Well, maybe you want to look at the bring your own device SSID, and you can send that to Wireshark as well. So, I mean, that just took me, normally that would take someone, a very long time in Wireshark to get that filter. Just took me seconds right there. Another one I want to show you here is one I made at the MetaGeek office. This PCAP was taken while I streamed Netflix from an iPhone to an Apple TV. And so quickly looking, I think this was on channel, let's see, what channel was this? 157. So this was in the 5 gigahertz. I dedicated my adapter to scan just channel 157. And the first thing you can see is MetaGeek is the dominant SSID here on channel 157. It looks like there was also another SSID here and here, but it looked like a pretty clear channel. So if I wanted to dive into this even further, it shows, okay, here's the access point that was taking up most of the airtime, which I was indeed at the Planck access point. And then this shows my 2 Apple devices. So one of these is my iPhone, one of these is the Apple TV. And then you can actually see that there's this little piece of data here, and then a ton of control frames here, aiding the delivery of those data frames. And so what's pretty cool about this is I'm going to go ahead and click inside the MetaGeek network here. So this is the network that I'm troubleshooting. I kind of want to show you this Analyze tab here at the top. What's pretty cool, since I already clicked in the MetaGeek network, there's already a check right here by the MetaGeek network. And we give these little insights here, which are really super neat. For instance, this says a high retransmit rate of 4%, and it kind of gives you a couple of solutions here. Maybe it's a Wi-Fi chipset issue. Maybe there's some networks that are causing some overlapping interference that you might want to look into, and it basically will say, hey, open up Chanalyzer, or open up this tool, or grab a spectrum analyzer and take a look. And then same with maybe there's some non-Wi-Fi interference occurring. So what's really cool is it kind of gives you some suggested solutions, and it shows you these insights on each channel. And this is something that we are just constantly working on updating, and we're kind of constantly looking at data and seeing if there's some of these that we can just automatically throw in there for you and get even more detailed and more advanced with. So this is kind of a recurring value that we like to deliver here in IPA, and pretty excited. We're really starting to, there's a lot of information you can gather in packets on these layer 2 conversations. And so we're excited to kind of deliver some more value there. With that, I think that ends my Eye demo, and I'll go ahead and open the floor up for some questions if there are any.
Hey, Casey, thank you very much for that presentation. Enjoyed it very much. And yes, I do have some questions here for you. Let's go ahead and start with the first one. Do you have any new products that are being worked on that you can speak to at this time, or is it a little too soon?
Since the last time, we do have a new product coming out that I can speak a little bit more about. We recently have partnered with another company called Osseum, and they're known more for oscilloscopes and kind of they are known as more of a hardware manufacturer are very similar to WiSpy, kind of spectrum analyzers and things like that. And so we hope to pretty soon here start to sell a mobile solution, something that'll work on a mobile device. And so we're really kind of starting to focus on that next. And it's kind of hard sometimes lugging around a laptop. And so we hope to introduce something that'll work with, iPhone, Android, things like that. So you just have less to worry about. And then you can still have spectrum analyzing and Wi-Fi scanning as well. So that's kind of the next big thing for MetaGeek right now, I would say.
Excellent. Thank you. We're looking forward to hearing more about that when the time is right. Next question here. Will the MetaGeek units work internationally?
Yeah, absolutely. Some people do think that the spectrum analyzers have some sort of active charge or something to them, but they're completely passive. They're just raw spectrum analyzers. Even the adapters we sell, they tuck into passive mode, and so there's no problems with that. And both those spectrums are used internationally as well. And so unless there's another band being used internationally more so than not, which I'm pretty sure there isn't, it should work great internationally as well.
Great, thank you for that. Next question. Are there training courses offered by MetaGeek to learn the software?
That's a really good question. We don't have like one-on-one training courses right now, but we do have a knowledge base, which is support.metageek.com. And I really recommend going to our knowledge base, which does have tons of articles and webinars and videos and things like that. And in the future, we've kind of talked about the idea of introducing kind of almost like a certification course for our software and kind of Wi-Fi knowledge in general. Right now, we don't have anything like that. Again, I would just recommend going to our knowledge base at support.metageek.com.
Great, thank you for that. Casey, next question. Can you talk about the Medicare warranty and when Medicare and when it expires and how it should be renewed and that sort of thing?
Yeah, yep. So Medicare basically just covers updates to the software at the moment. And so that's $100 a year. And basically, you can still use the software if your Medicare is expired. You just won't be able to grab any updates that come out after that expiration date. And it's kind of good to have too if you want support for a tool. You'll probably get deprioritized a little bit if you have like a 10-year-old piece of software that with no Medicare versus someone with current Medicare. They're going to get more priority when it comes to support services and consulting and things like that. But mainly the main value of Medicare is just to stay up to date.
Great, thank you very much for that. Next question here. Can you tell us the range of the SSIDE?
The range of the SSIDE, is that right?
Yes, that's what it says here.
Okay, I imagine what that person means is how far can you see SSIDs from other networks or from other access points. And really that just depends. If you are out in the open, let's just say you put an access point out in the middle of nowhere and there's no trees, no walls or anything like that, essentially it will travel forever until free space path loss degrades the signal enough. But really in open air, radio frequencies, it's basically RF. So as long as the RF can travel from a certain point, you can see an SSID from anywhere. And it also depends on the receiving whatever you're using to pick up the signal, the sensitivity is really important as well. So some people have been able to catch SSIDs from miles away, for instance, using a high gain antenna. And so really just depends what equipment's being used. But typically, like I was kind of showing you the ranges of the 2.4 and 5 gigahertz spectrum. So looking at about 300 feet for indoor range for 2.4 gigahertz and 90 feet for 5 gigahertz for SSIDs broadcasting on those two bands. Like I said, if it's outdoors, that pretty much travels, forever until there's something to attenuate it.
Excellent, thank you. And yes, that is what the after meant. So thank you very much for that.
Gotcha.
Great. Next question here. Does it work on all platforms, for example, Mac, Linux, and Windows?
No Linux, but it will work. Inside our office will work on Mac natively, which right now is our current only offering that I showed you that is available for Mac. Otherwise, the rest of the tools are Windows only. Hopefully, we will be able to change that in the future. I'm a huge Mac fan personally, but right now those main tools are Windows only, with the exception of inSSIDer Office. That one is compatible with Mac natively.
Great, thank you very much. A couple more questions here. In regards to the trial versions, can we demo all the versions available?
Yeah. Pretty much every piece of software that I demonstrated today is available for trial. One thing to keep in mind is that Chanalyzer does require a WiSpy in hand in order to really be fully functional and to get spectrum data in your environment. And so really the Chanalyzer trial, you can only open recordings unless you have a WiSpy DBX in your hand. Otherwise, the other two, Eye P.A does need to have some sort of packet capture adapter, but those are a little bit more common and they're cheap as well. You can get one for like $30, on Amazon. And then inSSIDer Office right out the gate is gonna be fully functional for you. Of course, if you did have a WiSpy, you can use that with inSSIDer Office as well if you do want to pull in that spectrum information. Yep, they all have trials available.
Great, thank you, Casey. Just a couple more questions. Let's see here. It can identify the number of devices connected to the same channel, but can it determine the name of the devices?
Yeah, that's a good question. Right now we don't. We can only see the MAC address of the client device. That kind of one feature that we want to include in the future is being able to alias that. So once you see that MAC address is on a channel, just being able to say, oh, that's my iPhone, and just alias that automatically. And that is coming here pretty soon. I'm pretty sure that information isn't broadcasted in any sort of probe request or anything like that. You would actually need to go through the router to get that information. That's why applications like Fing, you have to actually be on the network to get that information, like the client name. Whereas our tools, we passively scan everything. We don't actually connect to the network when we scan. And so, we can't get that automatically, but we are hoping to introduce an alias feature where you can actually input the name if you'd like to, because I think that'd be really neat and make that tool much more valuable. So that should be coming here soon.
Excellent. Thank you, Casey. Last request here. Can you send me the link via email to the knowledge base, and then I can turn around and send it to our team?
Of course.
That's the last request here.
Of course. Yeah. Again, it's support.metageek.com. Happy to send that as well to you as well, Julie. That's not a problem. Definitely.
Casey, thank you so very much for answering those questions, and also thank you everyone for attending today's webinar. And if anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. If you wish to view any of the products mentioned or shown today, please visit us at www.microcom.us. Please remember, the webinar presentation has been recorded and it will be uploaded to our Microcom YouTube channel, so if you wish to review it again, of course you can. Thank you, Casey, for your time today. Appreciate it so very much. As always, we always enjoy your presentation. Have a great day, everybody.
Thanks, Julie.